Good morning, everyone. My name is Addison Tyne, and I am the Marketing Specialist here at EAC. Before we begin, I will go ahead and start with a short introduction of EAC and what we do, and follow with a little more information regarding our strategic partnership with Simplification. Here at EAC, our company's mission is to transform the way that companies design, manufacture, connect to, and service their products. Simply put, this means that everything that we do to help your companies build better products is connected throughout our organization and yours. We don't see ourselves as another value-added software reseller. We see ourselves as a highly trusted business consultant. On the engineering side, we have a full staff of engineers that can assist with product development, consulting, or any other questions that might arise as you are trying to get new designs out the door. We also have an implementation staff that is ready and able to come on site to ensure that your PLM launch is nothing short of successful. We are putting on this webinar today in partnership with the Simplification Group, another Ansys channel partner in the Midwest, in order to utilize their technical resources as we continue our mission to transform the way that companies design, manufacture, connect to, and service their products. With that, I'm sure you've heard enough of the marketing girl for now, so I will go ahead and hand things over to Diane so we can get started.
Great, thank you very much for that. Welcome everyone today to this webinar session. I'm going to obviously talk about Icepack and the electronics desktop interface, but because I'm not exactly sure of everyone's familiarity with the software itself, I'm actually going to kind of start at the beginning. So before we get into the actual electronics desktop interface for Icepack, let's just talk about very briefly the next few slides about what is now being branded as Classic Icepack. So Icepack itself, if you're not familiar with it, it's an integrated electronics cooling solution that can be applied to all scales of electronic systems. It's really a specialized CFD package for electronics. And in terms of its capabilities, it can do laminar and turbulent flow, it can do conjugate heat transfer, so any combination of conduction, convection, radiation. There's also an option to do dual heating within PCB boards. There's steady state and transient thermal analyses, single or multiple fluids, species transport. You can do parametric and design point studies, optimization by linking it to Design Explorer software in the Workbench interface, capable of producing reduced order models to use in system level modeling, and multi-physics coupling to our other products. And I just want to say though that, we're talking about Classic Icepack here, but the vast majority of these capabilities are also within the electronics desktop interface. There are a few limitations right now because it's an early release of it, but eventually you'll see all of these capabilities rolled out within the electronics desktop interface. So again, let's talk about some features of the Icepack software that make it really beneficial for the application at hand. Things like model creation using things called edit panels. So it's almost like mini macros that can be used to set up some of these objects that are going to represent items within your electronics enclosure. We can interface to both ECAD, the common ECAD software produced by your common ECAD design houses, things like Cadence and Sukin and other types of Altium, those types of softwares. We can also interface to MCAD, common MCAD softwares as well, SolidWorks, Inventor, Autodesk, CATIA, and so on. The meshing routines are automated specifically for the electronics components that you typically find within these boxes. Again, we saw that all different modes of heat transfer can be included. There's some advanced modeling capabilities. Now, these are definitely within just the Icepack Classic interface, things like moving reference frames. Trace modeling, though, actually can be brought into the electronics desktop interface version as well. Extensive libraries of electronic components. Those libraries are within the electronics desktop, but not as extensive as they are in the Classic version right now. Both versions, though, are going to use the Fluent solver engine. Fluent's the best there is out there in terms of this a CFD solver. So they do use that solver engine. There's some macros that are available for customizing, for example, specific types of unusual heatsink configurations. Again, but that's only in the classic interface right now. The mesher, again, is unique, specific to Icepack, but it's also highly specialized to, again, fitting to electronic components that you typically see. And all of these different options have maybe a slightly different name in the electronics desktop interface, but these are available for the body fitting of CAD shapes. It's all there in electronics desktop. And they'll both take advantage, both versions of Icepack will take advantage of scalable HPC performance as well. And again, that multi-physics link to other Ansys tools, which I'll touch upon shortly. So here, the modeling fidelity, and this really holds true again for both softwares. You can start out with what would be considered a low modeling fidelity in the upper left-hand corner of the screen. So in classic Icepack, that would mean generating all of these objects within Icepack itself using the edit panels for each of those types of objects, a grill object, a heatsink object, a board object, fan objects, and so on. So starting from scratch, basically blank screen, building your entire model within Icepack. The intermediate fidelity model now says, okay, we're still within Icepack, for example, but now we're using maybe some of the macros within Icepack to build a detailed heatsink. We're also notice bringing in the trace information for the existing board. Our fans have gone from 2D to 3D. So that's a higher level object, a more advanced object, but it's still all done within the Icepack interface. And then the high model fidelity would be where we use MCAD as a starting point, and we would bring in some kind of a model, either through SpaceClaim potentially, or just as a step model, an IGES file, Parasolid, something like that. We can import that into Icepack. This type of workflow is also what you will expect to see within electronics desktop, and it would be much more common to use this high fidelity workflow than it would be to use the low fidelity, that is, building all of the objects within the electronics desktop interface. Typically, it's much easier. It's more of a CAD-centric software interface now, so you want to bring in your MCAD as a starting point, but you can always add objects to that within the interface. And just, from an overall standpoint, again, I mentioned the modeling capability across all scales of electronics cooling applications. So we're not limited to just doing boards with components. That means we can do, yes, boards with components, but we can also do the enclosures around them, and they don't have to be standard enclosures. You see a smartphone in the upper left. They can be a larger enclosure with multiple fans and multiple heat generation units, like the workstation in the middle. We can get into data centers where we have multiple workstations, multiple computing units that are in a large room, and actually model the airflow within the room to make sure that the room stays cool enough. The drone model on the lower right shows that we have a very complex shaped enclosure within Icepack, but yet we can import a board with traces into the drone itself, a control board, and do an analysis, see how much the board heats up, how much the enclosure will be infected by that, the drone body, smart glasses. And we can always do parametric studies and optimization, again, through the Workbench interface. So all of this is still available to us. The capability is still there in the electronics desktop interface. As I mentioned before, the solver is based on Fluent. It's, again, a very proven solver. We can do segregated analyses, so things like flow and energy, temperature and flow solutions, or we can just do one or the other. And there, again, there's that proven scalability with Ansys HPC. So on the right hand of the screen, you can see a study that was done on that desktop server model by Ansys to actually validate and to measure the scalability when you add HPCs into, the number. How does increasing the number of cores, how does that speed up your solution? And it's pretty much directly scalable. And then finally, in terms of results visualization, your classic, if you have a CFD software, your classic outputs from something like that are things like velocity vectors, temperature contours on cut planes on surfaces, fluid particle traces, isosurfaces. You can animate all of those, and that's all present here within Icepack. I actually have a couple of animations here to play too. So you can see as you take that cut plane of velocity vectors and move it throughout your domain, you can see how the drone body, the existence of the drone body affects those contours. You can also see, again, multiple temperature contours on a card inside of an enclosure, particle traces through that data center that I talked about earlier. It's all realizable. It's all available for animation within Icepack. In addition to the plots and the animations that you can do, you can also get just detailed reports with line by line listings of temperatures and so on, in any amount of overview or in-depth detail that you would like. You can even take that data and gather it, export it to an Excel file, for example, and then use that as an imported temperature map into a different software, for example. So many options to investigate and look at the results from your Icepack analyses. Okay, so now let's look at definitely kind of start introducing ourselves to the electronics desktop interface. So here is actually something that you would see more in the classic interface. So for those of you that have used it before in the classic interface, this should look pretty familiar. In the way, so in the upper left, we actually have a space claim model of just an electronics enclosure with a few heat generating components on it and a rather detailed heat sink, customized heat sink over one of them, over a large BGA. And the way this would be done is through the project schematic in the Workbench interface. So you would have your geometry, you would link it to your setup cell for Icepack, and then when you take that object, that CAD model, import it into Icepack, that's what you would see on the right typically. So, and a lot of people say it's not, it's a little bit of an archaic interface. Sometimes it feels like, but all of this now is available within the electronics desktop interface, which for those of you that are users of electronics desktop, it will become very familiar. And even if you're not, you'll see it's just a much, the interface kind of reflects the space claim interface a bit more with the ribbons and things like that. So this is that exact same model, but brought into electronics desktop. And we're going to go over the interface and the different parts of it and things a bit later in the session. But you can see that it's a much different, much cleaner, much more updated interface. And the thing is that just because it's an electronics desktop doesn't mean that we're limited only to models that are using EM losses as input. We can perform standalone Icepack analyses within this electronics desktop interface. Right, and the key to doing that is using the correct licensing. If you have a standalone Icepack license, it will unlock actually all three versions of Icepack. So on the left we have the new electronics desktop interface, which is new at Ansys release 19.1. On the far right is the classic Icepack interface. And in the middle we have this Icepack and SI Wave. So if you have an SI wave license and SI wave analyses, you can always open up and run Icepack in the background. Kind of a highly specialized usage of it, but if you notice for the electronics desktop interface and the classic interface, you know, we have mechanical, thermal, and electrical engineers listed under both now. So, you know, not your EEs aren't going to typically use the classic Icepack interface, but you'll find that they're much more open to using the electronics desktop version now, just because of the GUI that's used being the same and uniform throughout all of the EM products, the EBU products. All right, so let's start talking some specifics about electronics desktop Icepack. So one of the things, so we do still have the mesher that is unique to Icepack. This is not the same mesher that would be used for an HFSS project, for example. However, what has been added in is the capability to use this slider bar meshing that has always been available within electronics desktop. So it's a 5-setting mesher selection. I'll demo that in a little while, but you can see if we have a coil object here, you know, obviously some of the mesh settings don't make sense. You want to find that proper setting for the model at hand, but you can see how the different settings will capture or not capture the geometry. But this is not the only way to mesh. It's not fully automated. There are still, for the casual user, this is a good option. Someone who's not really familiar with Icepack but still wants to perform an Icepack analysis. But for the more advanced users who have been used to using Icepack meshing, all the classic controls are still available for those users. And I'll show you where those are located when we get into actually using the software. So this concept of mesh regions, in classic Icepack terminology, this is what is known as non-conformal meshing. Those have been rebranded to mesh regions in the electronics desktop version. And all that means is that we can take a subset of the parts within a model, and we can apply some different mesh controls, typically finer mesh controls, inside that sub-region or inside that box region. So it helps us to reduce the overall mesh count, but still maintain the accuracy that we need in our CFD analyses. So on the left-hand side, no mesh region, just a global mesh applied to everything. It's a board with a few components in an air region around it. You can see there's a heatsink in the package. And just because of the nature of the scale of some of the package items, you can see that the overall global mesh, in order to fully capture all this detail, there's a lot of mesh bleeding that's occurring. It's basically uniform, but it's kind of overkill. 1.5 million cells when we don't need that kind of fidelity in the entire region. So what we do is select just the heatsink, maybe the heatsink in the package underneath it, create a sub-region or a mesh region there with some finer mesh controls, kind of loosen up the controls on the global region, and we see there's a lot of that mesh bleeding has been reduced, and we've by an order of magnitude reduced our cell count, which is going to be much more beneficial for us when it comes time to solve this model. So it's, again, this is something that's really easy to do. I'll go over it in the software, but all you do is you basically select the assign mesh region command just by doing a right mouse click within the GUI. You click on the object that you want to apply this mesh region to. There's a bounding box that's going to be put around that. And then if you want to look at the actual properties, if you want to, you can still do the mesh, the slider bar meshing on these subregions, these mesh regions, or you can access the more advanced controls and have some a tighter control, a little bit more input in terms of how you want that mesh region to be meshed. One of the things that's been integrated here into Electronics Desktop into all of the products now is really something that came out of the Design Modeler and Space Claim, was the idea of these simplification routines. If you're going to use CAD and input that into Icepack Classic style, the way to do that would have been to actually do these simplification routines within Space Claim or Design Modeler. And what that meant was that not only were you maybe simplifying something to a simpler shape, which would allow for a less complex mesh, but you were also converting these objects into Icepack primitive objects, right? That was, Icepack will only operate on things that are identified as primitive objects. So the simplification routines were kind of twofold in terms of why you would do that. So now we have simplification routines within Electronics Desktop, but it's not absolutely necessary to apply them to every single object. So when they're automatically, when you import, say, a step file into Electronics Desktop Icepack, it's going to come in as all CAD objects, and it will be meshed. You don't have to do any kind of intermediate simplification routines. It will mesh, it will function as a CFD model. But the advantage here is that, again, to be more efficient about how we, create our mesh, to be more computationally efficient during our solution, these simplification routines are a good idea. And there's different levels. There's just 3 different levels here. 4 were in Classic Icepack because, remember, we don't need that CAD simplification anymore because that's the default. But there's a bounding box, which just basically captures the object with a box around it, and then there's a primitive fit and a polygon fit. Primitive fit will break it into just cylinders and rectangles, cylinders and blocks. Polygon will try and capture some of the nuances of the geometry, if there are any there. And we'll talk about these during the demonstration of the software. So there's also this option, though, to separate any of these bodies into primitive bodies as well. So I like to think of it as a Lego building block approach, right? If you can take this object and you can create the same thing out of Legos, that's basically what you're doing with this kind of separating into basic shapes. But there are huge advantages to doing this from meshing standpoint, especially when you have much more complex objects like this. To be able to almost take this kind of stair-stepping approach to creating this object will lead to much less, it'll be much easier to successfully mesh and solve a model that has this body represented as separate primitive bodies. And again, it's a one-click operation too. So it's nothing. You don't have to go through and manually split all those surfaces. It's literally just something that you select the body and you select the simplification routine that you prefer. One click of the OK button, and it's all done, and all the bookkeeping is taken care of for you. Regarding flow and thermal inputs, obviously we have to have some kind of manual input for the thermal and flow options that are happening here in the model that need to be present. This is, again, very simple, very, very easy to do. All you have to do is select the geometry that you would like to apply the thermal input to. Right-click in the pop-up window, you choose the Assign Thermal option, and then you have several options that will appear at that point. So these are the kinds of thermal inputs that are available in Electronics Desktop right now. So you can identify objects as either blocks or sources, which are going to be your power dissipating objects typically. Blocks are 3-dimensional, so it applies the power dissipation in a volume. The sources are just 2D surfaces, representations of power dissipation. And then you have plates. So your thin objects, it's almost like a surface object in structural modeling. It's a 2D representation of something that you don't want to mesh the thickness of, but you need the representation of it there. Grills, openings, and resistances are all going to be for flow restrictions to provide flow passages. And then walls, you may have some thermal boundary conditions you want to apply on the exterior of your region, your air region. And then we can also have EM surface and volume losses, and those would be available when we have a linked solution from an EM product such as HFSS or Maxwell or Q3D. After we assign these thermal inputs, then in the feature tree, in the history tree, in electronics desktop, you'll see there will be thermal objects that would be listed in the project manager window. Sorry, not the history tree, in the project manager window. And I'll show how we'll look at that and see what that looks like in an actual demo of the product. One of the things now available for Icepack by using the electronics desktop interface, something that was not available previously, is this idea of scripting. You could not script in Icepack before this, but now, as in all Ansys products, there is a capability to record and then run scripts. So you can apply this to kind of fully automate a design process, for example. So you hit the record button, go through several user operations, and they can be geometry creation operations, it can be material assignments, assigning boundary conditions, and so on. That's all captured and recorded. And then you can actually, using the Iron Python command window, you can actually now use those scripts and put it into an automation type of loop. So something that's, again, a really significant advancement in terms of Icepack. So that multi-physics link is available and pretty straightforward. We can map power loss into Icepack from any of the electromagnetic products. So it's a dynamic link, and we saw that a couple slides ago on when I reviewed how you assign thermal inputs to objects. They were the two that were listed in the bottom. Once you activate those thermal assignments, then you'd have another window that's going to pop up and ask you, okay, so where are these losses coming from? And you can just select, go through the selection in the drop downs. Set up the link according to the which source design specifically you're using, which project, which solution out of the design if you have multiple solutions. So it's all relatively straightforward. So again, we can take different frequencies from a source design. If we have multiple solutions at different frequencies, we can pick which one we want to use, and so on. And then once we do that, we can go through an iteration to solve and update the source design based upon the thermal results. The other way to activate this coupling between the EM products and Icepack is through an ACT extension. So once you activate this extension, what it does really is the same thing that was just done on the previous slide, the dynamic link, but it does it all automatically, meaning that you don't even have to start with the Icepack solution. You actually start with the electromagnetic solution. And there are some limitations. You can either have forced or natural convection. You can specify some flow directions and whether or not you have gravity. And then also some of that slider bar meshing option, you're limited to one of those settings. But what happens is the Icepack design is created kind of behind the scenes, so you never really have to open up like the Icepack version in electronics desktop. The link is done automatically. The entire generation of the Icepack model is done automatically using the existing model in the EM product. And it will adjust all the solver settings to the best practices depending upon how these options are set in your ACT window. All right, so that is the end of that the presentation. So what I'd like to do next is to actually go into the software and show you what this all looks like now. Maybe point out some of the differences, show you some of the options and things like that. So here we have actually a couple of projects that are in this file. I'll again go over the GUI in a minute. The Icepack models that are in Electronics Desktop now you'll see will have the same file extension that the other electromagnetic products use. That's a .aedt extension. You can also archive or compress the models, and that would be a .aedtz extension. So those are all, that's how the files will look when they're saved. It's really easy to add in an Icepack design. All you have to do is you just say click and insert an Icepack design, and that's basically it. And you will browse it'll automatically insert a design. Right now you cannot open, and this is probably going to be a big question for everyone, but you cannot open a classic Icepack design within the Electronics Desktop version right now with the existing version of the existing release of Ansys. That is something that's on the roadmap in the future, though. That is being planned for. So that's good. We'll be able to open legacy models, legacy Icepack models within the Electronics Desktop version at some future date. The help, there's a lot of help that's available. So just drop down your help, and you'll see that you have your basic documentation. There's scripting. There are getting started guides. Right now, there's not a lot available for Icepack, but there is one getting started guide. And just some an automatic link to customer support. What's new in this release and things like that. So the help should improve somewhat. The help that is available, hopefully, now that it's in the Electronics Desktop setting. All right, so let's talk about the interface. So on the left-hand side is the project manager. So you can see, again, I actually have two projects, and one called Icepack Demo, which has two designs under it. One is called Meshing, one is called Simplification, and then I have another project called PCB Assembly, which is a fully solved one. Underneath that, so if I can expand this. I look at under my simplification design here, and if I click on some object here within the history tree, you'll see that the properties for that object will come up in the properties window. If I double click on that, the properties window will actually pop up right in my GUI area. There's also ribbon menus across the top. I'll talk about that in a minute. Obviously, my main GUI window here. I have some component libraries available on the right-hand side. So there are some, as I mentioned, it's a little bit limited right now, but there are some libraries available in terms of fans and heat sinks and packages right now. Down lower right progress window, when I mesh, when I solve, you'll see a green bar comes up. And we have a message window in the lower left that will interface with me somewhat. The ribbon menus across the top, you'll see this kind of looks a bit like the space claim interface here for those of you that have used it. You have your desktop, where that's when you're starting, or inserting designs into your existing projects, your file controls, standard viewing options in terms of hiding and showing, and rotating and orientation, fitting. Here's your draw menu. Your draw menu, as I said, what's going to happen here is you can actually draw, from scratch. You can create objects from the ground up. Probably not the easiest thing to do. I do not personally use it myself very often. The model tab here shows, again, some geometry preparation. The simplify, there's those simplify routines, align faces, remove faces, are a couple of several options there that are used pretty frequently. And you can see there's your import geometry. And if I had the proper version of space claim installed, to match this 19.1 version, then you would also see the connect and browse to space claim options being activated as well. So that's all your preparation. And then when you actually want to start to kick off the simulation, there's your meshing options, there's your analyze all. Once you actually want to solve, there's a validation check that's available as well. And then once you have a solution, obviously all your results are going to be entered in the results tab. Automation is where you find your scripting recordings and runnings. Okay, so in terms of the display itself, every time you bring in a new model, you'll see that there's an air region that's automatically created around it. So I like to just kind of shut that one off. Kind of viewing wise, I turn that off because otherwise every time you click on an object, you're going to click on that large region first. But you can toggle from, so this is, a great interface. We can toggle back to that wireframe interface that seems a little bit more familiar to us in Space Claim. And sometimes it's a little advantageous. You actually, in order to select objects, it is easier to do it when you don't, when it's in the wireframe mode. So there's a toggle to go between wireframe and solid viewing. Again, we talked about, some of these objects. So if I have something activated here, notice though, when you bring in some kind of a set file, just like in a structural model, for example, that, material is not defined. So if I wanted to define, assign a material to that, all I have to do is say edit. It brings up the library of materials. So it's all the same library that we see in classic Icepack. It's all there. You can search by name if you would like. So, and that's all very easily and readily done right there. One of the interesting options here is the solve inside button. Basically what that does for a block is it turns it from a hollow block to a solid block. If it's checked, the object in the interior is meshed, heat conduction solved. If it's not checked, object is not meshed inside, but it will have a surface mesh. There's also this idea of model versus non-model objects, which those are non-model objects are like suppressed objects. They'll be there and available, but they won't be included in the solution itself. So as I mentioned on the draw tab, there's a lot of different options to create objects. Probably not something you really want to do, but there are many times that you want to do some kind of defeaturing of an object. So for example, in this model right here, I can use the CAD as is, but if I want to be more efficient about meshing it, I'm probably going to do some kind of simplification or defeaturing options here. So one of the things I can do, for example, is I can go into, let's look at one of these tall capacitors here. Let me pick it here. Let's go this way. All right, I'm going to hide all the other objects here. So all right, there's my capacitor. Let's put it into solid mode here. So one of the things I might want to do, typically what you do is, the rounded surfaces here, you want to take those off. So if I actually go into, let's see, it should be under my model tab. I'm going to select the faces on the top. Once I select them, I can say remove, and that's, kind of a typical thing. If you're a Space Claim user, you've seen this done over and over again. So that's one of the, geometry defeaturing options that's typically used. Let's show all, fit. Again, let's go back to object selection mode. Let me hide the region. Let me go to, let's do the housing. All right, let's hide everything else here. One of the things, this housing, this one-piece housing, pretty simple in terms of shapes, but again, probably something that I want to break down. And maybe it's a little too complicated to use those simplification routines, so I can split off objects. So again, what I'd want to do, and this is actually in the draw menu. So if I select the housing and then I go to split, and then all I have to do is pick the face that I want to split it on. There's some options here in the window that showed up in the upper left-hand corner. I can split using planes. I split using the selection. I want to keep both sides of this. I don't want to get rid of one or the other. And I just want to split the object that crosses this plane. I don't want to split everything that's in the model. So I just say OK. And then what happens, you can see now, is those fins have been split off as individual objects. Again, that's beneficial from a meshing standpoint, most definitely down the road. I also, one of the other options, there's like an align faces option where you can, it's like a pull command in Space Claim. It'll take two objects, if there's a gap between them, between the faces that are parallel to each other, and it'll pull one face towards the other depending upon what order you select the faces in. So those are some common, oh, let's also go to, let's show everything, and then let's go to, let's look at this object, the coil part of our transformer. So again, remember one of those options here. So if I select, you notice one of the things with electronics desktop is it likes to a pre-selection of things before the command will be activated. So if I click on simplify, so I selected the object, I clicked on simplify. And again, here's my option to do, a bounding box, which would, literally be just a box around that. I can also do, a primitive fit or a polygon fit. And I can, typically it's an extruded object, works really well with a polygon fit. I can, if it's a curved surface, I can determine how many points on an arc I want to capture that curvature. And, I can say, okay, sometimes what happens with these simplification routines is like I lost the hole through the middle. That may or may not be important from a thermal standpoint. So I may want to go in and, add another block object in there to represent as a hollow block later on. It all depends upon, like I said, the thermal aspects of this particular model and whether or not I want that hole or not. All right, let's look at a different model now, a different design, something, it's pretty simple, pretty straightforward, but let's just talk about the different meshing options now, how this is different from classic Icepack as well. So those are, again, remember under my simulation tab, I would go to my activate global mesh settings. So there's that slider bar meshing that we see, and in all reality, fine is very fine. So you don't really want to start with, even though it's a simple model, you don't really want to start with that first. So maybe, and I'll just show you a coarse model, what that looks like. So you can say okay, and let's see, we're done with that. Okay, the meshing model will tell me when the mesh has been finished. And then in order to look at it, I forgot to generate. Okay, I set the setting. Now I have to generate it. Okay, and you'll see in the progress window, there was a very quick pop-up there. It didn't take long to generate this. Now I load it. And now I also, I turned on a mesh viewer as well so that I can see the resulting cut plane mesh. I can look at the surface mesh that's on the object. So if I pick the board, I can see the surface. So you can see it's pretty, and if I pick that circular capacity, it's kind of atrocious. Let's admit it. So I can actually do an unload mesh here now in Classic. So I can get rid of that mesh. I can go back to my global mesh settings and say, well, let's see, maybe I want, a 2 or a 3 even, and say okay. Then I can generate mesh. This one's going to take a minute longer or so. But then you'll see there's really a large difference. And you can even notice that it's taking a little longer for the mesh to load. You can see the number of elements at the top there. You can definitely see now, there's a residual selection here of that capacitor, and most definitely a difference in terms of the mesh sizing that results. If I look at the cut plane through this, you can see cut planes, I can always, dynamically adjust where that plane is going to be. You can see, there's automatic mesh settings, knowing that these are all actually CAD objects, and here none of them have really been, I don't believe, simplified into primitives yet. You can see the multi-level meshing that's being used to try and capture the cylindrical shape of that capacitor object. Let's see how we're doing on time. Okay, a few more minutes. Let me just also mention the mesh regions. How do you actually create those? So again, it's really straightforward. All I have to do is, for example, if I wanted to put a mesh region around two of these components down here, I can select them. I can do a right mouse click and say assign mesh region. So I do that. Notice the meshing region comes up. I can use the slider bar meshing if I want in the mesh region as well. So if my global mesh is at a 3, I might want to go to a 4, say in my mesh region. I can also go to this advanced tab, and this is where you can now access the controls that are more familiar to the classic users. So in terms of max element size and minimum gaps and enabling or disabling multi-level meshing and so on. So those would be familiar to the classic Icepack user. But once I assign that mesh region, I closed my window without actually assigning the region, and I want to say it has a mesh setting of 3. I say OK, and then what happens, you see in the property manager, the project manager, excuse me, there's the mesh region has appeared. Once I click on that, you can see it shows me where it is. You can also see that it's now actually a non-model object that's been created, and there's the box object that's been created around it. Frequently, for classic Icepack users, what you like to do is introduce what's called slack region around that. So you don't want it to, the edges of the mesh region to coincide with the edges of the objects themselves. You can add slack to this by going to, by actually editing the box, arranging and adding an offset. For example, would add a continuous offset all the way around the object. You could also go into the actual object itself and actually tweak the dimensions of it if you wanted a non-uniform offset all the way around. So that's mesh region. Assigning, as I mentioned in the presentation, assigning thermal inputs is extremely easy. So I just assign thermal. If I want one of these objects to be a block object with volumetric, power, I get a window that pops up, and then I can just type in a value. Notice I can also make that a fixed temperature object, or it can have some internal conditions as well. I just say OK, and then once I've done that in my project manager, you can see there's all the options for that block object now have been recorded and notated and included. And then last thing I want to show before we open it up to questions is I have a solve model here. It has many more thermal conditions, so you can see there are some thermal conditions in terms of the blocks and standard power dissipation. There's also some plates here, those two-dimensional objects that can have like a thermal resistance associated with them, for example. So that's one of the reasons you would use that type of an object. We have some openings here that have been defined with an ambient temperature and an ambient pressure. So basically a free opening, but also notice that the standard results are available. So there's some velocity vectors, there are some temperature contours, and then if you actually look at what's known as solution data, there's your convergence monitor. So, almost anything you can do in classic Icepack is really available in this electronics desktop interface now. So that's pretty much, I can see we're coming up on almost on the hour here, so I'll stop talking now and open it up to see if there's any questions.
All right, thanks, Diane. Yeah, we've got several questions in the Q&A, and then we have a few in the chat.
Okay.
I know the one, I'll let you catch your breath for a second. I know there's one that said HPC, what's HPC, that you mentioned kind of at the very first. I mean, HPC is just high performance computing, and it's where you're taking a model and breaking it up and allowing multiple computers. I mean, it could be one computer with 8 processors, or it could be 8 computers with a single processor. But anyway, you're breaking the model up and allowing multiple CPUs to solve the model. And that's one thing that CFD lends itself to is parallel computing, or allowing multiple processors to work on a model. It's very good at that. So.
Yep, and I see in the Q&A window actually is pretty much all one related question, and the question is about can Icepack model heat at the PCB trace level? So basically, can you model the effects of PCB traces within this electronics desktop version of Icepack for heat spreading purposes and the equivalent thermal conductivity, things like that? And the answer is yes. The one caveat, though, is that in order to bring in the trace data, right now it has to go through the HFSS 3D layout software. So unfortunately, if you don't have an HFSS license, then you won't be able to do it right now in in electronics desktop Icepack. That is the conduit right now. That's the translator that would be used to generate that. So there would be that you would bring the model into HFSS 3D layout, and then you would set up that, you would actually copy that into an Icepack design. So that's the workflow for that right now.
Okay. So yeah, there's a couple over. If Diane, if you could open the chat window, else I can read the questions out. But
okay. Yeah, meshing. How can you improve meshing for complex CAD geometry? That would be setting up, primarily doing a lot of that, the mesh regions, assigning mesh regions around the CAD objects is really the best way to do that. When can you introduce TET? There is really no TET meshing for Icepack. Actually, Icepack really, as most CFD programs really have a preference for hex-dominated meshing. Because otherwise the TET elements become too skewed for the CFD solution to really converge. So, you can still capture the complexities of the CAD geometry using hex meshing, but that's when the multi-level meshing options become very critical, and setting those enough layers of those up and setting all the buffer layers and inflation layers and things like that effectively. Is it possible to introduce some tools inside to clean some features such as blend, chamfer, filling unwanted holes? Yeah, I mean, like that, remove faces will fill the unwanted holes. Sometimes, like unwanted holes, I didn't show in one of the models I showed up, the first one. The PCB board had some really small holes in it. So effectively, since that board was a rectangle with some small holes, the best thing in that case would have been to apply a bounding box simplification on that one, because that would have automatically filled in the holes and maintained the shape of the board. So, it's definitely, there are tools that are available to do that. SpaceClaim obviously has some great tools to do that. So if you can do most of your defeaturing in SpaceClaim, that would be excellent. But if not, there are some subsets of those tools in electronics desktop. And I answered the question about converting existing Icepack. Converting existing Icepack license to. No, as I mentioned, if you have an Icepack license right now, a full license of Icepack, it will work in the electronics desktop interface. The only thing that's going to have to happen, though, is I do believe you have to have a new license key generated so that you have the line increment for the GUI for electronics desktop. You don't have to pay extra for that GUI, but you will have to have a license file that would include that option. Let's see, is it, oh, this is like multiple questions here. One chat, is it possible to meshing from complex? Yeah, no, okay, so like I said, complex CAD geometry, right. So either keep it CAD geometry, use mesh regions, and be very selective about some of the, go into your advanced meshing options and make sure that you're applying those efficiently. Simplification can work on CAD geometry, absolutely. I showed in the presentation how we had that complicated heat sink that ended up being, with one click of the simplification routine, it was simplified into, probably like 30 sub-bodies. But you can group things. In terms of organizing, there's grouping that's available as well. In the project manager, you can do grouping, or I'm sorry, not the project manager, in the history tree. You can go in and you can group objects and things. So that's it. There's maybe a little bit of bookkeeping you can do, but you can select things by using the shift keys, do group selections, and form a group. And then it's all captured, and it's the same thing in classic Icepack though. I mean, that really isn't going to go away, and it really can't go away. You have these individual objects now, but if it's just a bookkeeping thing, you can group them in the history tree. On-screen selection. Oh gosh, yeah, I was doing it in the demo. Absolutely, you can select things, you can select objects, you can select faces in electronics desktop. You can select edges, you can select vertices. Oh yeah, absolutely. On-screen selection is available. I was doing a lot of that. I don't know if you noticed or not. Actually, that's why I turned off the region from showing it when I first open up those designs, because if you click on the screen, because that's your largest object and the one that's closest to you, that was always the one that was selected. So I would select it with a click and then just hide it. Right, and so again, that ODB++ for PCB import, once again, that would have to go through the HFSS 3D layout conduit in order to get it into Icepack.
Okay, there's one more question came in on the Q&A about Icepack dealing with natural convection.
Yep, yep. So classic or electronics desktop version, it's the same thing. Natural convection is, I'm not sure, it's kind of an open-ended question in terms of how it deals with it, but if you mean, can you do buoyancy effects and things? Yes, that is available. That's an option. I guess you might have to, be a little bit more specific about what you're asking, but it is available as, it's not just forced convection that can be solved within Icepack. You can do, and you can also add radiation too. I didn't go into detail in that. There are actually 2 of the 3 radiation models that are available in classic Icepack are available in electronics desktop Icepack as well. So any combination of, again, it's a conjugate heat transfer solver. So conduction, convection, radiation, all of them going on at once. Yes, it can handle that.
All right. I don't see any more questions. We'll give it another few seconds here. If you do have a question, please feel free to type those in, else we'll go ahead and close this out. And again, everyone will get a link. You'll get an email from the Zoom people like you did for the registration. And in that email tomorrow, there'll be a link to the recording for this. So, if you miss something, I know Diane went pretty quick through a lot of things, but it's a good way to go back through and kind of, you can narrow down what you missed and kind of view that.
Yeah, sorry, there's just a lot of information to try and cover. It's an overview, but there's just so much complexity to the products that it's tough to just kind of give a 1-hour overview.
Sure.
I don't see any other questions coming in, so why don't we just go ahead and close this out for now. Thank you, Diane, for your presentation, and thank you everyone for joining us this morning. Hopefully we will see you on another webinar soon. If you have any questions, please feel free to reach out to our Ansys simulation specialist with the contact information I have provided here, and have a great rest of your day.